All right, hello. This is a walkthrough of Mastery Exam FB, practice version 1, and we're starting with problem 1 here. So FB, function basics, it's all about working with functions in ways other than plugging numbers into them. Plugging things into functions and simplifying the results is really what FA is all about, function algebra. Here, though, we want to think about things like the domain of a function and other related things. So we're being asked to give or state or find the domain of a function given by this formula in correct interval notation. So let's think about what a domain is first of all. That word refers to all the acceptable inputs that my function can have. So one way to approach this problem here is to think about, just play with this function and think about what can I put into this function and what can't I put into this function. Now some things I can put into this function are just fine. Like if I try to calculate f of 10, and that would be 3 plus square root of 10 minus 1. Okay, and I can compute that. That's 3 plus radical 9, that's 3 plus 3, and that's 6. I get an answer if I put that 10 in. But other things I can't, like say f of 0. Right, that would be 3 plus radical 0 minus 1. That's 3 plus square root of negative 1, and that right there is a problem, right? There's no real number that whose square is negative 1. And so that gives me a non-computable result. So in other words, 0 is not in the domain of this function, but 10 is. So hopefully that orients you to the idea of domain, but we can't just guess and check and expect to get all the numbers that fall inside the domain. I want to find all the domain, all the x's that work in the sense that we just discussed. So how do I approach that problem? Well, I look back at my formula and I look for what was causing the domain issue when I was playing around with examples. Well, it was this. It was the square root. There are problems that result if I try to have an x that gives me a negative number under the square root. Okay, that's not good. So in fact, the domain of this function I can find by just finding all the values of x so that x minus 1 is bigger than or equal to 0. Okay, whatever x values make this inequality true are going to have no problem going through this function, like 10 or 2 or even 1 is okay, but anything less, anything that makes x minus 1 less than 0 is out of the domain. So the things that are in the domain that do give me computable answers are the x's such that x minus 1 is bigger than or equal to 0. Now that gives me an inequality. It's actually fairly easy to solve that inequality once I have it. I just add 1 to both sides. All right, so the domain, the set of all x values that work in this sense, are all the x values bigger than or equal to 1. However, we're not done with the problem because I now have to go and write the result in correct interval notation. Now, we've learned about interval notation in your high school algebra classes, and we've covered a little bit in Math 135. What I want to have here are all the x's that are bigger than or equal to 1. So I can start at 1, but there's no limit on how big they can be. I'm going to go from 1 to infinity. And interval notation requires that I put either a square bracket or a round bracket on either end of this, not both, but one or the other, depending on whether I include the endpoint or don't include the endpoint. Now, infinity is not a number, so it can't be included. That's always rounded when I have infinity. 1, on the other hand, is that included in the domain? Well, yeah, it is, because this domain is the set of x's that are bigger than or equal to 1. Or another way to think about it is, could I plug 1 into the function? If I can, then it's in the domain. So f of 1 is 3 plus radical 1 minus 1. Radical 1 minus 1. That's square root of 0, which is 0. So 1 is in the domain, so I'm going to include it. All right, and that's my domain in correct interval notation. All right, so to recap that, let me just clear off the junk on my I've drawn up here. How do you determine the domain of a function? Well, you look at the formula and look for trouble spots. Anything in the formula that could possibly cause a computational error, like a square root, and in other mastery exams you see things like 1 over x minus 2 where the fraction has a potentially 0 denominator. Sometimes the domain is the entire set of real numbers. There are no computational problems. But look at the algebra that's over here in the formula and look for computational problems. Turn that into an inequality that avoids the computational problems, solve that inequality, and then rewrite it as an interval.